Hello viewers, in today's session we are going to discuss another important problem from application of derivatives, and here we are going to discuss this problem related to increasing and decreasing functions. So here we have to find out the intervals in which this function, that is f of x, is equal to cosine cube x, where x belongs to this interval, that is from 0 to 2 pi, is increasing and decreasing. So we have to split this interval, that is from 0 to 2 pi, where this function f of x is increasing and decreasing. So here we'll make use of the concept of derivatives to find out the required intervals in which this function is increasing and decreasing. So let us first quickly see the definition of increasing function and decreasing function in terms of derivatives. Suppose we have a function, say y is equal to f of x, which is defined in some domain D, right? And if this function f of x is continuous in some interval, say a comma b, and it is derivable in some open interval, say a comma b, then this function is said to be an increasing function if the derivative, that is f prime of x, is greater than 0 for all x belonging to this interval, that is a comma b. And this function is said to be a decreasing function if f prime of x is less than 0 for all x belonging to a comma b, right? So these are the definitions of increasing function and decreasing function in terms of derivative. So when the derivative is positive, that is f prime of x is greater than 0, then the function is said to be increasing. And when the derivative is negative, that is f prime of x is less than 0, then the function is said to be decreasing. So here we'll make use of this concept to find out the intervals where this function f of x, that is cosine cube x, is increasing and decreasing. So from this function cosine cube x, it is evident that the domain of this function is the set of all real numbers, right? So now let us find out the derivative of f of x. So f prime of x is given by d by dx of cos cube x. Now here by using the power rule for differentiation, the derivative of cos cube x is 3 times cos square x, and then by chain rule we have to differentiate cosine x. So now we have 3 cos square x, and here we have the derivative of cosine x as minus sine x. So the derivative of f of x is given by minus 3 cos square x, and here we have sine x. So now this is the derivative, and now we have to find out the intervals. So for the function cos cube x to be increasing function, this derivative should be greater than 0. So it implies that this term, that is minus 3 cos square x sine x, should be greater than 0. So now let us look at this expression. So here we have a negative sign, and here we have cos square x, right? And for all x belonging to this interval, that is 0 to 2 pi, cos square x is going to be a positive. So here cosine square x is always greater than 0 in this interval, right? So here now we have to concentrate on this term only, because for this expression to be greater than 0, this sin x should be a negative, right? Because here we have already a negative sign, so sin x should be less than 0, or sin x should be a negative quantity for this term to be greater than 0. So now from the sign convention of trigonometric functions in four quadrants, here we have 0, and then we have here pi by 2, here we have 0, then we have pi, here we have 3 pi by 2, and here we have 2 pi, right? And this is first quadrant, this is second, this is third, and this is fourth. Now from the sign convention of trigonometric functions, we know that the sine function is positive in the first two quadrants, and it is negative in the third and fourth quadrant, right? So now f prime of x should be greater than 0 for the function to be increasing function. So it implies that this term, this entire term has to be greater than 0, but cos square x is greater than 0 because this is a square term, right? So this term is positive, and here we have the negative sign, so it implies that sin x should be less than 0. So sin x should be negative, so that the product of this negative with this negative is positive, right? And sin x is less than 0 in the third and fourth quadrant. So when x belongs to this interval, that is from pi to 2 pi, right? So when x belongs to the interval pi to 2 pi, then sin x is less than 0. So this function is increasing for all x belonging to pi comma 2 pi, because in that case sin x is less than 0. So sin x is negative, and the product of this negative sign with this negative sign is positive, so that this entire term is greater than 0, that is the derivative is greater than 0. So in this interval, that is from pi to 2 pi, the function is increasing function. So now for the decreasing function, this derivative, that is f prime of x, should be less than 0. So it implies that this term, that is minus 3 cos square x sine x, should be less than 0. So now this term cos square x is a positive term, and here we have the negative sign, this is positive. So this term to be less than 0, this sin x should be positive, right? So now in case of decreasing function, this term, that is sin x, should be greater than 0, or sin x should be positive. And from the sign convention, we can easily see that when sin x, that is x, lies in the first and second quadrant, then sin x is positive. So when x belongs to this interval, that is 0 to pi, then sin x is positive. So this entire term minus 3 cos square x sin x is less than 0 when sin x is greater than 0, or sin x is positive, or x belongs to this interval, that is 0 to pi, or x lies in the first quadrant or in the second quadrant. So now sin x is positive. So the product of this negative with this positive is equal to negative and f prime of x is less than 0. So the function is said to be a decreasing function when x belongs to this interval, that is 0 to pi, right? And in case of increasing function, we have here sine x as negative. So the product of this negative with this negative is equal to a positive, which makes the derivative greater than 0, right? So f of x, which is equal to cos cube x, is increasing in the interval pi to 2 pi and decreasing from 0 to pi.